Welcome back to episode 9 in our series on databases and database users. This one might be just a touch longer than the rest, but I'd like to go ahead and finish up this series with this lecture. So bear with us, pay attention, and let's get rolling. Most database applications have certain integrity constraints that must hold for the data. A database management system should provide capabilities for defining and enforcing these constraints. The simplest type of data integrity constraint involves specifying a data type for each item. For example, the student ID number must be an integer, or the student's name must be alphanumeric. A more complex type of constraint that frequently occurs involves specifying that a record in one file must be related to records in other files. This is called a referential integrity. Why do we use referential integrity for our mystery word in this video? You recall earlier when we were talking about that student information systems that we had a student relation that contained a student ID number. And we had a grade report relation that contained the student ID number and the grade and the section ID of the section that the grade was earned in. Well, a system must be able to ensure that the student ID number put into that grade report relation was in fact a legitimate student ID number in the student table. If a user or an application were allowed to input data into that particular column that did not exist in the student table, then the integrity of the system would be damaged. That's referential integrity. Another type of constraint specifies uniqueness on a data item value, such as every record must have a unique value, such as a part number for an inventory item or an ID number for a student. This is known as a key constraint. It is the responsibility of the database designers to identify integrity constraints during database design. Some constraints can be specified to the database management system and automatically enforced. Other constraints may have to be checked by update programs or at the time of data entry. It is customary to call such constraints business rules. A data item may be entered erroneously and still satisfy the integrity constraint. These errors must be identified manually through the use of business rules. For example, we said a moment ago that the student ID input into the grade report relation had to exist in the student table, and the system can ensure that. But the system can't really ensure that the ID number input is the right one. It would be possible for a user to put the wrong ID number in there and the system would not catch that. Therefore, there must be business rules in place that will require users to double check their entry and things like that to catch these kind of errors. There are other advantages to the database approach to system development. There is the potential for enforcing standards. The database approach permits the DBA to define and enforce standards among database users in large corporations. This facilitates communication and cooperation among various departments, projects, and users within the organization. Standards can be defined for names and formats of data elements, display formats, report structures, terminology, and so on. You recall that the student ID number had to be an integer? This can be enforced. The DBA can enforce standards in a centralized database environment more easily than in an environment where each user group has control of its own data files and software. Another advantage to the database approach is reduced application development time. The prime selling feature of the database approach is that developing a new application, such as a retrieval of a certain data from a database for printing a new report that takes very little time, designing and implementing a large multi-user database from scratch may take more time than writing a specialized file application. However, once the database is up and running, substantially less time is generally required to create new applications using a database management system. Development time in a database management system is estimated to be 1/6 to 1/4 of that is required by a traditional file system. Flexibility is another advantage. It may be necessary to change the structure of the database as requirements change. For example, a new user group may emerge that needs information not currently in the database. In response, it may be necessary to add a file to the database or to extend the data elements in an existing file. For example, if one needed a new file for some particular application, it's very easy to create in a database management system. Furthermore, if you recall our discussion earlier about program data independence, adding that new relation for that new piece of information does not affect the programs that have already been written to access the database. If you had to add a new column to the student table, doing so would have no effect whatsoever on the applications that access that database in a database management system. It's quite the contrary in the traditional file approach, where the application is counting over columns looking for a piece of information. Modern database management systems allow certain types of evolutionary changes to the structure of the database without affecting the stored data and the existing application programs. Well, my goodness, that's just what we were talking about, isn't it? Availability of up-to-date information is better in a database management system. A database management system makes the database available to all users. As soon as one user's update is applied to the database, all other users can immediately see this update. This availability of up-to-date information is essential for many transaction processing systems, such as a reservation system for those cars, or the airlines, or banking customers. It is made possible by the concurrency control that we talked about earlier. That, in fact, I believe was one of our mystery words. And recovery systems of the database. There are also economies of scale. The database management approach permits consolidation of data and applications, thus reducing the amount of wasteful overlap between activities of data processing personnel in different projects or departments, as well as redundancies among applications. This enables the whole organization to invest more in powerful processors, storage devices, or communication gear, rather than having each department purchase its own lower performance equipment. This reduces overall cost of operation and management. Relational databases were originally proposed to separate the physical storage of data from the conceptual representation, and to provide a mathematical foundation for data representation and querying. The relational data model also introduced high-level query languages such as SQL that provide an alternative to programming language interfaces, making it much faster to write new queries. And there you have it. We have finished the discussion of databases and database users. We will be moving on to another chapter in future sessions, but right now go ahead and input your mystery word for this one, and then go check your knowledge in our coursework section to see how well you picked up the material covered in this episode. And then we'll get together again later for a whole new topic.